Okay, hopefully you can see me. So this video is to explain the coagulation cascade, aka shortening Dr. Cottle's good, really good, but very long lecture into something a bit more chewable, we'll say. So first thing you want to do is you're going to draw a very big Y, and think of this video as like you're learning the rules to a board game for the first time. So as we go, it'll like make a little bit more sense, excuse me. So we're gonna make this big Y. Okay, that's probably not a big enough Y for this video. Let's see. It's a relatively small Y for this video. Okay, we'll make a bigger Y. Doesn't matter how like you make it, but so you can see it better. We'll make it bigger now. Okie dokie. Okay, so you have three different pathways within the clotting cascade, right? So you have intrinsic, which is gonna go here. Extrinsic is gonna go here. And lastly, the common pathway is the straight part of the Y here. So there are a lot of different numbers in the coagulation cascade, so we're going to come up with a fun little way to memorize it easier. So all we're going to have to do is count down from 12, but first, let's get the common pathway, because this is kind of the bridge between the two branches, right? And in my opinion, before you go out into branches or before you go out into the big details, you want to get the baseline of knowledge first. This is kind of built in the same way, okay? So Dirty Meds talks about it on YouTube, and he says that think of this as a common math problem. So we'll say a common math problem. And when I say common, I'm meaning like elementary, middle school math, right? Whoops, probably elementary school, but don't know where everybody went to school. Okay, so common math problem. So what is a common math problem? Well, we have 2 times 5 equals 10, right? So taking these symbols out of here now that we have our little memory tool out of the way, the common pathway factors is going to be factor 2, factor 5, and factor 10. So just reminding everybody, these can also be placed in Roman numeral format. So I'm going to put those to the side. Okay, so now we want to go ahead and start on intrinsic, because remember, you read left to right. So we want to start on the left, just like a book, just like a regular math problem, right? And we're going to start to count down from 12. So we're going to have 12, 11, 10, 9, 8. There's not too much room left, right? I don't want to force it in, so I'm just going to jump over here and say, okay, well, 7. Okay, make sense? So the problem now is we have 2 10s. Well, we already put it here, so we don't need it twice. So just take this one out. We don't need to. So now what you can see is the intrinsic pathway is going to include factors 12, 11, 9, and 8. And remembering Roman numerals, we could have 12, 11, 9, and 8. So just in case, I mean, I think everyone knows Roman numerals by now, but just in case you don't, because there's a lot of basic knowledge that I didn't understand coming in, is if the little 1 or the little dash or I, or whatever you want to call it, is on the left side, you're going to subtract. If it's on the right, you're going to add. So 8 is 5, which is that V, 1, 2, 3, 5, 6, 7, 8. 9 is 10 minus 1, so it's 9. Did you need that information? Probably not, but I just want to cover all the bases while we're here. Okay, and then extrinsic, we only have 1, so pretty fun and easy to remember. So we're going to have just number or factor 7. Ta-da! Okay, so now we're going to talk about some diseases that go into these. Now, why is this important? Well, It's important because if you don't know the factors and how the cascade works, then you can't actually know where the diseases go wrong and what those lab results are going to look like. So if we go in, let's start with our bleeding problems. I put it in lowercase, I wanted it to be in uppercase. Okay, so we're gonna have increased bleeding time, increased PTT, and increased PT, okay? So, increased bleeding time, the only reason I'm starting with this one is just because I think it's one that most people have heard of, or it stands out and people can remember it pretty easily. So under increased bleeding time, we're gonna have something called von Willebrand's disease. So we're gonna spell it out, von Willebrand. And I'm not gonna write out disease, I'm just gonna write out von Willebrand, but you get the point. So if you don't know already, von Willebrand affects something called the von Willebrand factor, as well as something called factor 8. So next to it, I'm gonna put von Willebrand factor and factor 8. Okay, cool. So when we say increased bleeding time, right, that literally means that when the person gets a cut, because this is coagulation cascade, right, we are trying to make a clot. So if any part of this gets messed up, we either get hypercoagulable and make too many clots, or we can't make enough. So weird thing about that is they kind of present the same, and that's why these lab values and these things that we're going to talk about matter, because when somebody with any kind of pathology in this pathway gets a wound, they're going to bleed for a really long time, or they're going to have a harder time making clots. And you're thinking, oh, well, they can't be hypercoagulable because they're not making a clot because it won't stop bleeding. And I mean, when I say won't stop bleeding, I mean nosebleed for 6 hours, paper cut for 4. It's an abnormal amount of time and an abnormal amount of blood. But what really happens is a lot of the time, and we'll talk about each one individually, probably in a different video if it's needed, but this is just a memory tactic for now. So what's weird about a lot of these is they will be a hypercoagulable state, or they'll be making an excess amount of clots. But the reason that they keep bleeding is because the clots are forming wherever they want. So when you do get a wound, there's not enough factor 8 or von Willebrand factor, whatever factor we're talking about, to make the clot at the wound site because it's spread everywhere else, right? So it's kind of in a weird way, if the chef is hungry and he's been making the food, but he's been sending it out to all of the students in the school, but there's none left for him. Kind of the same thing of like, oh, but now I need it here. It's too late. You already sent it all out. It's already all taken up in the blood. There's no more free factor, whatever, to actually go and do its job. So you're going to have risk of clots like a PE, a DVT, etc. At the same time, you're going to have a risk of bleeding out. So keep that in mind as you read through Dr. Caudle's slides, because I got a little bit confused on that at the beginning, and then boards clarified that a lot for me. Okay, back to it. So von Willebrand, right? So big thing we're seeing is factor 8, because von Willebrand isn't on here that we've listed, right? We just see factor 8. So we're going to go over to factor 8, and I'm going to write a little note to myself that, hey, this is von Willebrand, okay? There's other ones in here. So we also have, I'm going to write them in green. I'm a liar. I'm going to write them in orange. So we also have our hemophilias on this side, okay? So we do have hemophilia A and hemophilia B. And why am I not going into these? Because unless you ask, I don't want to bombard you with information. So hemophilia is over here, von Willebrand's is over here. Ugh, my goodness. gracious. Okay. And these matter because, so the intrinsic pathway, right? So there's a couple things you need to know. One of them, let's scoot this up a little bit so we have some room. Okie dokie. So one of them is that to be in this, you're going to have something called an increased PTT. An increased PTT. And the next thing, and these are not in like an actual numerical order of importance or chronologically, I'm just numbering them so you see that there's multiple things to look at and that they're separate entities. So you have the increased PTT. You also are going to see the intrinsic pathway triggered when you use heparin. Okay, so with this, when I say there's an increased PTT, and that's all I've listed, I am automatically also confirming that you have a normal PT and a normal BT or bleeding time. Okay? So, of course, extrinsic is going to have things as well. We're going to have extrinsic up here. Okie dokie. So extrinsic, if this one is increased PTT, down here is increased bleeding time. This one, of course, is going to be increased PT, our only one left. Thereby implying, or therefore implying, a normal PTT and a normal BT, or bleeding time. And then for the extrinsic pathway, if heparin's this one, what's another really common blood thinner, but more adverse effects we like to watch for? Drumroll, warfarin, right. So this one is going to be triggered by warfarin. I have no idea how to spell warfarin right now because I'm tired, so ignore if that's wrong. Okay, so how do you remember this? You're like, okay, Haven, thanks a lot for all the information. It doesn't help, sorry. But how you can remember it, or how I remember it at least, is for intrinsic, let's draw, for intrinsic, there are more numbers, right? This side has 4, extrinsic has 1. So I'm gonna say this side with the 4 has more numbers. So since there's a higher number of numbers, there's also gonna be a higher number of letters. And what does that mean? Well, instead of PT, which is 2 letters, it's going to have an increased PTT, which is 3 letters. So higher numbers means the higher letters, okay? And then of course for extrinsic, the same is true from the other direction, that extrinsic has a lower amount of numbers because it just has factor 7, okay? So lower numbers is equal to lower letters, which is going to be PT, only 2 letters. Okie doke. So, those are the big ones. As for the drugs, okay, I just like to think, I would like to exit the war. I don't want to be fighting in war. I'm not built for war. So, I literally tell myself, I would like to exit the war. And what does that mean in terms of memory of this drug? Exit being extrinsic and war being warfarin. How do I remember heparin? Well, it's the other one. So that's how I remember those. Okay. Then we're going to go back down to this bleeding time. So the bleeding time is a little different. Besides von Willebrand, who as we can see has an increased bleeding time, but it affects factor 8 too, right? So what else is this going to be impacting? A PTT. So if you ever see a bleeding disorder with labs of an increased bleeding time and an increased PTT, you can answer that question. Well, that's von Willebrand. It's the only one that does that, okay? So that's the one that it impacts 8, so it hits PTT. It's also This section over here, unfortunately, is just going to be a little bit of memorization, but there's only 3, so it's not too bad. But as long as you remember von Willebrand is factor 8, you can kind of, what I say, pull the string on the shirt, which means follow that thread all the way through. You'll be able to get to where you need to go. Okay, so we have von Willebrand. And I'm also numbering these. Once again, this is not in any kind of chronological order or a priority order. I'm just ordering them with how they come to my mind. So another one we have is ITP. Okay, and these all stand for the same thing, but the big thing you need to know here is that I, which means idiopathic, but I like to think of it as immune. Okay, so this is idiopathic, but I like to think of it as immune. Why do I like to think of it as immune? Because it's triggered in immune settings, or it's triggered after you've had like a viral infection. Okay, so ITP is going to have an increased bleeding time. Okay, then we have TTP, and TTP these seem about like the same thing, and in boards they also seem about like the same thing, but one of them follows like a viral infection and one of them doesn't. That's the big difference. So you see increased bleeding time on any kind of lab setting, you automatically are like, okay, bleeding time specifically. I don't care how they say it. If they say there's an increased bleeding time, it's not talking about this. It is only talking about one of these 3. But okay, it's either von Willebrand, it's ITP, or it's TTP. Got it. Okay, so then, okay, well, do they also have an increased PTT? If the answer is yes, we're looking at von Willebrand. If the answer is no, we're looking at ITP and TTP. And then we have to see the disease progression from there. Did this follow a viral illness? They don't have to tell you that. They could say, this person was on an antibiotic last week. This person had flu-like symptoms. This person's feeling under the weather lately. Anything to trigger you to, at some point in this timeline, this person was sick. They're not going to throw that in there unless they're trying to tell you one of these 2, okay? Okay, so one little extra guy, and as you go through with this, you can go through Cottle's lecture, or if you want details of like exactly where all the diseases are, these are the really big ones that they ask about, is these 3 and these 2. But if you'd like to see all of them, tell me, and I'll keep this up and I'll make another video and add them in and explain them a little bit better. Just let me know. But one of the things that a lot of people do ask about is vitamin K deficiency. Okay, so what do we do with, that's my husband, sorry. What do we do with vitamin K deficiency? Do you know what factors vitamin K deficiency impacts? It's okay, I'll tell you. So the answer is it's going to affect factors 10, 9, 7, and 2. And I like to just go in with like a little dot of like a color when I'm drawing this myself, because I'll draw this a few times before the block, or I draw it a few times before boards, just to kind of walk myself through everything. And then I'll also be like, this person has bleeding gums. What is that a buzzword for? And I'm not going to speak on those again until you ask me to, but go through the lecture, find some buzzwords, tag them in, and be like, okay, hemophilia, it has this, and now I'm looking what factor is it affecting. Okay, this one, plug it in, talk yourself through the scenario, and you'll be fine with like that entire lecture. Okay, anyway, back to it. So we have factors 10, 9, 7, and 2. So we have 10, 9, 7, and 2. Do you see why this could be concerning? Because if vitamin ignore that. If vitamin K deficiency happens, we're not only affecting the intrinsic pathway, we are affecting the intrinsic with factor 9, the extrinsic with factor 7, and the common path with factors 10 and 2, meaning every part of this coagulation cascade now has a kink in its armor, we'll say. So there's no strength about this cascade when vitamin K is happening, okay? So, how do you remember this? And this is really all you have to know. Cottle will give you buzzwords of specific things that bleed. Like all of these disorders, like I was saying, will have, this one has bleeding gums a lot. This person is in boys, like just boys that their dad and their grandpa and their great-grandpa all had it. There's going to be something to trigger you to each of these besides the factors, but you do have to know both. I wouldn't overstudy it to a degree, just find like the primary symptoms, do this, and that should cover everything. Okay, so vitamin K, 10972, I just like to say 1972, as do most people, I think, studying this. So you just remember, okay, vitamin K is 1972. Why this? Because the rest of them are self-explanatory, but this one is like 10 plus 9, and then it's just 7 and just 2. But it's the quickest way. Like, if you did like 10,972, sure, but then you just might as well remember the numbers. 1972, for some reason, just clicks with me as well as a lot of other people. So, vitamin K. So for the most part, I think this covers like the base knowledge. I think I did go over time a little bit from what my goal was, but that's okay. So just one more thing, not one more thing, just to round up. We have intrinsic and extrinsic pathways. We have our common math problem, and that's 2 times 5 equals to 10. And then we want to count down all the way down to 2 from 12. So we go 12, 11, 10, but we already have it, so forget about it. 9, 8, oh, ran out of room, go to 7, okay? And then where are the rest of them? There are other ones. They just don't matter. So that's why they're not included. That's been cross-referenced on literally pathoma, sketchy, first aid, coddle, tutoring, like everywhere you look, dirty med. The rest of the factors don't matter, except for, I didn't want to talk about that. I'm going to talk about one more. Okay, let's do it in pink. Okie doke. So, there is one that I like to forget about, but I shouldn't. So it's called Leidens. I think that is how you spell it. But the big thing you need to know about this one is Leidens or whatever is a factor 5 deficiency. What is bad about factor 5? It's the common pathway. So does it affect intrinsic or extrinsic? Correct, it's both, right? So since it's in the common pathway, anytime one of these is knocked out, you're cutting off, think of a tree, you're hitting it right at the trunk. So it doesn't matter where the branches are, you've killed all of it. This is the same thing. So Leidens, and I'm gonna check the spelling, but I think it's that. It will cut out factor 5, which means it will have both an increased PTT and an increased PT. And you primarily see this on the labor and delivery floor. So you see this a lot in pregnancy, and you see it a lot in delivery. So that one's always a pretty bad one, but most of the time they're gonna give you some kind of situation where a woman is either pregnant or going to have baby and is having severe bleeding problems, whether that means she is giving birth and is bleeding a drastic amount and hemorrhaging, whether that means she's in her 2nd or 3rd trimester and she got a cut and it won't stop bleeding, something to trigger you. They're saying pregnant or baby, think, okay, there's only one of these that specifically is in them, and it's factor 5. All of the questions I've ever gotten about that are, here's the scenario, what coagulation cascade pathway is going to be messed up, or what factor is going to be deficient in this person is factor 5. Okay, I think those are the big hitters. I hope it helps. Let me know if you need anything else.